Welcome back to Maths with Mrs. J. We've been talking about factorisation and we've learnt about taking out the common factor. We've also learnt about the fact that factorisation is basically the opposite thing of expansion. So if you're expanding, you're removing brackets, you're changing something from a product to a sum or a difference. And if you're factorising, you're turning something into a product, into factors. Something that we did meet in our expansion videos was difference of two squares. And we did talk about how if you were to expand this out using your FOIL technique, the middle term actually cancels out, because what happens is you get a times a, which is a squared, minus ab plus ba minus b squared. So your minus ab and plus ab cancel out and you end up with this. This is called a difference of two squares for obvious reasons. This is something squared. Difference means minus something squared. You need to be able to recognise this pattern when factorising. All right, let's do some examples. I've got some challenge ones here that you certainly wouldn't be doing on your first day of doing difference of two squares, but I do like to aim high and I do like to challenge people. So certainly by the year 10 level, you would be expected to be able to do something like these. So I will be showing you how to do them. Let's start with some beginner level ones though. If we've got x squared minus 9, we need to recognise that that is a difference of two squares. For starters, it's a difference. We've got our minus sign, and this is something squared, and 9 is also something squared. So we've got a difference of two squares. Then we need to know that all we need to do is we make two brackets with those terms in them. One bracket has to have a plus and one has to have a minus. It does not matter which order you write your brackets in, as long as one of them has a plus and one has a minus. And so that would be correct. Just checking, if you were to expand that back out again, your negative 3x plus 3x, that middle term would go. Let's have a look at the next one. It's a difference, yes. Of two squares, yes. This is really x squared minus 5 squared. So we get x minus 5, x plus 5, or x plus 5, x minus 5. It really doesn't matter which order you put the brackets in. All right, difference of two squares. Well, 4x squared is really 2x all squared. 81 is 9 squared. So we're going to get 2x plus 9, 2x minus 9. So far, so good? Okay. Now this next one here, yes, it is a difference of two squares and we could proceed straight away. However, what will happen is each bracket that we get will have a common factor that we then need to bring out. It is way easier for us to take out our common factor first, and now we've just got our x squared minus 1, which is going to be our x plus 1, x minus 1. If you were to do it as 2x all squared minus 2 all squared, you'd get two brackets like this, and then you'd have to take out a common factor of 2 out of each, and that's a bit of a pain. Perfectly doable, but you're way better off taking out your common factor to start with. With our next one here, if we were to not take out a common factor, we wouldn't even be able to recognise the fact that this is a difference of two squares. Let's take out our 2, because it's a common factor, and now look what we're presented with. That's a very obvious difference of two squares, so we can get our two brackets there. Okay, x to the 4th minus 16. Well, x to the 4th is really x squared squared. 16 is 4 squared. So we're going to get x squared minus 4, x squared plus 4. Now, are we done? We're actually not done yet. There's nothing more we can do with that bracket. But look, we've got another difference of 2 squares happening now. This is x squared minus 2 squared. So we've got an x minus 2, x plus 2, and this is x squared plus 4. This one here cannot be factorised in the real number system. Why? It's not a difference of 2 squares, it's a sum of 2 squares. It certainly is not x plus 5 all squared, because remember, when you do that, you get your middle term. So there's nothing you can do with this. Don't be tricked by this. It's not a difference of 2 squares, this is a sum of 2 squares. Okay, are we ready to tackle our challenge questions? Let's have a bit of a look here. I'm going to colour code and see if that helps us. So, do we have a difference of 2 squares? Well, yeah, we do. We've got x minus 2 all squared minus x plus 3 all squared. So it is appropriate to go ahead and do our 2 brackets. Let's do that, but I'm going to do bigger brackets like this and put our little brackets in there, just to be extra careful. So we're going to have our x minus 2 plus our x plus 3 and our x minus 2 minus our x plus 3. Just with our colour coding situation happening there. So there's our first bit and there is our second bit. So it's like a squared minus b squared is a plus b, a minus b. Okay, well, the first bracket, you've really just got a 1 in front of each of these. So it's really just x minus 2 plus x plus 3. So you've got 2 x's, minus 2 plus 3 is plus 1. This one, because we've got a minus outside of here, we're going to take an extra step just so that we're extra careful here. So we're going to subtract x and we're going to subtract 3 because there's really like a -1 outside the front of that bracket. Now, tidying up this bracket, x minus x actually goes and you're left with -5. So we'll bring that number right out the front. If you do have just a number, a constant, you generally write it out the front. Okay. This one, next one is even a little bit more tricky, but we can certainly manage it. What are we actually dealing with here? What we've actually got is we've actually got 2 lots of 2x plus 1 all squared minus 3 lots of x minus 2 all squared. Okay, because 2 squared is 4 and 2x plus 1 squared is 2x plus 1 squared, because 3 squared is 9 and your x minus 2 all squared. So now we're going to do our big bracket. So we're going to do this plus this, this minus this. It is a difference of 2 squares. We just need to be a little bit careful here because we are going to have to do some expansion and gathering of like terms, etc. Sometimes part of factorisation will involve some expansion along the way. It's just the way it is. So we're going to get 2 lots of 2x plus 1 plus 3 lots of x minus 2, 2 lots of 2x plus 1 minus 3 lots of x minus 2. Okay, so we're going to get 4x plus 2 plus 3x minus 6, 4x plus 2 minus 3x plus 6. You've got -3 times -2. Tidying up again, 4x plus 3x is 7x, 2 minus 6 is minus 4, 4x minus 3x is x, 2 plus 6 is 8. And there you have it.